This is our project report. This one is mainly about introduction, experimental operators, procedures, and this one is mainly focused on report theoretical section. Third is mainly about the project calculation. These are some steps about the calculation. The last one is the conclusion about our project. Thank you.
Hello, doctor. My name is Lin Zihao. I'm responsible for the experiment preparation of experimental equipment and the execution of experiment. And the first part is introduction. This experiment explores the fundamental relationship between fluid velocity and pressure within a finite space. The setup consists of a functional prototype, a cylindrical pipe fabricated from an A4 sheet of paper and a 5-cent coin. By applying airflow through the pipe, we demonstrate how aerodynamic forces can be harnessed to move a solid object against its resetting inertia, a concept central to many engineering applications. So the second part is the experimental apparatus. We use A4 paper and a 5-cent coin and adhesive tape. The third part is procedures. First, I wrote a standard A4 paper into a cylinder with a diameter slightly larger than the 5-cent coin. The seam was sealed using adhesive tape to ensure a smooth internal surface and to prevent pressure loss through gap. And then the pipe was placed on a flat horizontal surface. The coin was inserted into the pipe and positioned near the inlet. Finally, I blew air directly into the pipe, and then I noted that a sharp, high-velocity burst of air was more effective than a slow breeze.
Hello, doctor. Good afternoon. My name is Zhongfu. I was mainly responsible for investigating and coordinate team members to carry out the experiments. When blowing coins into a cylinder, the theoretical knowledge involved include Bernoulli's principle. Bernoulli's principle is a fundamental law of fluid mechanics. Its core content is that in the steady flow of an ideal fluid, there is a negative correlation between the fluid velocity at a certain position. The lower the pressure, the lower the fluid velocity, the higher the pressure. When air is blown horizontally at the opening of the cylinder, the upper surface of the coins comes into contact with the high-speed airflow, where the air velocity increases sharply and the pressure decreases accordingly. In contrast, the lower surface of the coins is in a relatively static air environment with a low velocity and high pressure, thus creating a pressure difference between the upper and lower surface of the coin. So in the end, all of this theoretical knowledge was put to use to blow the coin cut of the cylinder. Then that's all. Thank you.
Hello, teacher. This is my fleet part. It is the calculation part. And the fundamental principle of this is Bernoulli's equation. And the formula is P 加上 0.5 rho v 方加上 rho gh 等于 constant. And the key parameters is that the diameter of the 0.05 is 0.023 meter, and the radius is 0.011 millimeter, And the final formula is that the FG rho v min 平方乘 area 等于 F friction, and the final VMI is 5.93.
Hello, doctor. My name is Ma Yufu.
Conclusion. The primary objective of this project was the demonstrated integration of analytical, experimental, and numerical approaches to solve a specific fluid mechanics problem involving a head flow prototype. Based on the results obtained, the following conclusions are drawn. Validation of theoretical models. The experimental data collected from the functional prototype showed a high degree of correlation with the analytical predictions of the Rome Bernoulli's principle and the Darcy-Weisbach equation. The conclusion is that the flowing at coins is related to the airflow rate, and the larger the coin blow out, the faster it moves.